first episode in a series of webinars brought to you by Darwin Recruitment. So my name's Lewis Adams Dunstan, and I head up the US division of Darwin Recruitment, where me and my team focus all of our time on providing end-to-end technical recruitment solutions for our clients across America. And in this particular series, I'll be partnering with some of the industry experts to dig much deeper into the trends and challenges in natural language processing. So to kick us off, I'm going to be speaking with a good friend of mine and one of the very few true experts in the field, Mr. Danius Boomer. As a quick intro into Danius's background, he's a PhD in machine learning and computer science with a focus on deep learning, natural language processing, and artificial intelligence. He's got over 10 years of industry experience as a data scientist, an engineer, and a research team manager, and has been involved in both startups and some more recognizable multinational corporations during this time. He's also sat as a visiting scholar in the NLP lab at UH, and most recently was appointed as a senior scientist of NLP research in Aon's dedicated IP solutions group. Danius also has a very active research background with papers accepted and under review for a number of the top natural language processing conferences worldwide. Today, he's actually going to be giving us some insight into the state of the art in natural language processing, the biggest open problems, and what to expect in 2020 from his professional perspective. So welcome, Danius.
Thank you. Well, should we start? I think the current state of the art in the natural language processing is, developing quite rapidly, and it's if anybody's familiar with the concept of transformers or multitask learning in general, basically a certain kind of a revolution, I would say, has happened maybe 2 years ago. What we know as the ImageNet of NLP, because the deep learning revolution, what has been kicked off in around 2012 by Geoff Hinton, who published a paper called on a dataset called ImageNet, and who shattered all the accuracy and prediction benchmarks for that. And a very similar thing happened around a couple of years ago, or 1 year ago, with 2 or 3 discoveries, and some of the important ones are deep language models and transformers. And what is the main idea is, you teach. We're beginning to create an artificial intelligent mechanisms that can multitask, that are not just focused on things like strictly classification or strictly search or strictly recognition of some kind of lexical rules, but they can actually do pretty much anything you throw at them in the same way, much the same way like a human would, and they can transfer knowledge across time. They don't have to be retrained over and over. And that's kind of the secret behind things like BERT, which is many people are familiar with. Go ahead, Lewis. And that's it. I think that's the biggest state of the art in NLP. And if anybody has any questions, let me know. So now, what is the kind of current top model? And I think it goes without a question. It's called XLNet. It comes out, again, it's a brainchild of Google. And it is something that has it is capable of beating human intelligence and human baselines on many occasions. And so where does it leave us? There's things like XLNet, there's things like graph models from Facebook, but that leads us to overly hyped kind of situation, where today what is perceived to be state of the art really isn't, because I have been trying to, for example, me personally, with all the resources of my company, which are quite considerable, has been trying to actually use those state of the art models, and in most occasions they're not very actually usable, which is quite interesting, because well, if you're a Google engineer, you can afford to throw, what is called a TPU, or like a pod of TPUs, and spend a few $1 million training your model. And most startups do not have that kind of money, and in fact, most corporations don't want to spend that kind of money. So, which leads us back to the question: what is really a state of the art of NLP if 99.9% of people cannot use those exclusive models that are defeating, they're competing between each other on very, very specific tasks. And I think to answer it, there's a very simple answer, and it's kind of interesting that this model does not come, or this library that has been kind of taken the NLP world by storm, and it's created by one of the inventors of the deep learning revolution, Jeremy Howard in San Francisco. It's a fast AI library, and it came out maybe a couple of years ago. And it was the original ULM fit model that started it all, that they have been using and iteratively improving. And the interesting thing about it is that this whole group of people that created it comes from a guy with a major in philosophy from Australia, and I think high school math teacher from France, and a few people. Like I think other than Sebastian Ruder, none of them actually have PhDs. I think now maybe the main guy, Howard, got the honorary PhD. But so the practical things that are actually used in the industry, and for example, people like attorneys or people like law firms or doctors, and not necessarily just only computer scientists, but actually that other people can also understand that do not have PhDs in machine learning. So these tools are created by very smart people that do not have a formal education, and they're quite competitive. So for many years, this ULM Fit has held the top results, and it's still maybe behind getting beaten by BERT and whatnot by 3 or 4% in all the tests. But as Howard has said once in replying to somebody saying how great the new transformers are and how fast they are, so have you actually tried training them? So it's not a very easy task. So back to the main point of your whole question. If you look up any kind of academic paper, and you look up what is SOTA, so-called state of the art, and you'll find that a million answers, and most of them is going to be ExcelNet, Kearney, BERT, all this great Elmo characters, from all these cool popular models. And ULM Fit is a cool popular model. It's very actually, it's a lot of people go to take this class on how to develop it. But the thing is, I think basically it's the same library that has been holding strong for about a couple of years, and they've been updating it. For example, yesterday they introduced a new loss that they just bumped up the results a couple of percent. So I would highly recommend to use that for as many tasks as you possibly can. And so that would, because that is for any kind of reasonable person, that is the state of the art.
I think it's interesting as well, because state of the art is quite a broad question. But if we were talking about, and I'm not sure how much you can share, but the work that you guys have been doing at Aon, using and introducing natural language processing as a tool to assist with the things that you guys are doing. I'm not sure if you can share about that, but that's pretty state of the art for the insurance industry, right?
Yes, and I can share some information, and so I cannot share exactly what we're doing or why we're doing it, but
yeah, of course,
it goes without the question that of course we deal with a lot of documents, right? And of course a lot of them are legal documents, a lot of them are other kind of documents, but the corpus of documents that we're dealing with, and that's also, I think, so that I guess we're just going to have to be all over the place here, but I guess this kind of smoothly transitions into what are the big open problems, is because, okay, so there is a story to share. I had an intern, and we wanted to do some kind of high risk, problem with him, right? Because, it's you don't want to dedicate a team to something, but so we said, okay, let's train ExcelNet with it. So we gave him a month to train it. The problem was that we had a 200 gigabyte corpus with millions of documents and like tens of millions of documents. And of course, by the time his internship was done, it was only 1 month internship. This big model, it did one cycle on the thing, so it hasn't really done anything. So with those kind of problems that we deal with, actually, they are still, very often I find myself looking at big data papers or trying to kind of merge this, or like there's a huge kind of interest on my part and a few other folks to try to mix, and that's another actually interesting thing, because the latest ACL had I think more than 900 submissions on this topic, and it was never like this. It's graph neural networks or graph NLP, where things are like, if anybody has heard of the term of a knowledge graph, like a Google's knowledge graph, where they connect different taxonomies, and that's something they've been keeping very secretive about. But I'm aware that Facebook has released their graph, and now Pinterest is doing also a graph. Basically, kind of try to. Because that kind of help. Okay, so if you can try, basically, if you have a bunch of documents, you have millions of documents. If you can kind of narrow it down using some kind of a link, like page rank, like fast algorithm, down to a group of documents that you have to work with, and then you can use maybe deep learning, because you cannot possibly do it on all of it, right? So I guess that's kind of the idea, to try to help things, help speed things up, and of course, like memory neural networks come into play with this. But we have been playing with all these advanced tools, but and I mean, in production, still very often we find ourselves using things like logistic regression, and it's just because something is not like hot or cool, it doesn't mean it's not the latest thing in NLP. It doesn't mean that in the industry it should not be used, or because like one of my favorite jokes is like how and I'm a deep learning person, but we tried every deep learning trick in the book, and then in the end the linear support vector machine won. So basically, it's a 25, 30-year-old algorithm that I'm talking about. It's usually very tough to beat. So yeah, go ahead.
No, and I think certainly what's interesting, just from the outset, for people who aren't necessarily involved in data science, machine learning, natural language processing, this whole idea of building these tools to take over people's jobs is crazy, because for the most part, the stuff you're building is to help support process that has already been happening for a period of time, but to make things a lot more streamlined and a lot shorter. That's my understanding of the kind of stuff you guys are doing now, right?
But yeah, I would say we're, yes. At first, I thought we would be like it would cost people jobs, and maybe it would be a bad thing. But no, actually, it costs jobs in one way, but it creates jobs in the other way. Because I think the very same people that are no longer doing something because of the products that we're building, they usually they're internal products, right? And but they're not like dismissed. They go into doing working with those products and using them, and it saves them time. And I think it's just in general one of the big things about AI in just outside of NLP. I think that when the Industrial Revolution happened, before the Industrial Revolution, it's a kind of very famous fact that I think on average you spend 2 or 3 hours doing laundry every day, and I think so every time with every advent of technology, we will need to spend less and less time. So I think within 5 years you won't have to type. You'll be able to talk to the computer and very comfortably. You already can, or even think, there is a brain-machine interface kind of developments going on. So
yeah, it's amazing.
I think within 20 years NLP will be a solved problem for the most part.
So what are the challenges? What are the main challenges we're facing right now in general across the natural language processing space?
Well, I think yes, I think for me at least, that's my personal thing. One of the main challenges is as I mentioned, this kind of Well, maybe just to you privately. There's a little bit of a disconnect, between industry and academia. And for example, things like large document classification or problems that are like this in NLP, they're not very thought after, and usually things like that are actually maybe less interesting to us, but like some kind of inference or entailment tasks or natural language generation task. It has been getting a lot of attention, but or some, we're still not quite sure how to apply it or where to leverage it, sometimes. And I mean, because chatbots are great, but they're kind of, okay, they're limited, right? So
Yep.
I understand that I understand the main point, like once we solve the natural language generation task, when we actually have machines talk just like humans, that will be like a complete revolution, right? But for now, like there's a lot of tasks at hand where, okay, like when I have as I mentioned, like a lot of stuff to classify, for example, or to search, or back to TF-IDF you go, or to whatever is, so kind of people still use in the industry. SQL is very much one of the main tools, and actually SQL search free, indexing, is search, and it's still used very much. It's very much so. There are companies that don't even use machine learning; they just use Excel and SQL.
Yep.
So yeah, so that's one of the main problems. Another main task is definitely natural language understanding. And understanding is it's I guess it's the realm of the multitask learners, and it's something people like Sebastian Ruder have been working on, and a lot of people, just generally people in Google Brain and Facebook AI research more recently, and MSR. But basically, it's to create. The idea is simple as that: to train a model on several things, and to have it, and from knowing all those things and all those concepts about our world, it can actually make connections about when you ask it, when it's confronted with new kind of type of problems or tasks that it has not been trained on. So it's more like a step towards a general AI.
So we're talking more like common sense AI now. So a system that can basically explain and justify answers.
So yeah, something beyond the simple pattern matching. What is very because otherwise, unless it's like I forgot who said it. I think maybe I want to say Likun, but he said that unless your AI can answer the question that it has not been has not seen anything like them in training, but can still understand, and then whatever it is you think you're doing is just glorified pattern matching. And I think we're getting there, and I think the big step towards that was in terms of going back to step of the art was GPT-2, the infamous model that was too dangerous and they got removed because it did. What happened was that actually, it produced a quality of writing of text that was mathematically proven that it could not have been generated without some kind of intelligence going on. To put things simply, right? I'm not going to explain too much, but basically this was a kind of a first bell. And of course, it's not going to stop anything. So I'm sure it's going to be kind of a wild ride and quite interesting in that regard. And so what else? I think one of another big problems in NLP right now is that's still it's kind of open. I think it's it's a multi-modal learning. So which is by that I mean, let's say today I think it's NLP is still kind of a thing in itself, but we are starting to branch out, and we already have companies that are like for example, chemical startups, biomedical startups that are seeking to use either language models, deep language models, because they are sequencers, or graph models to combine information from past research of papers and from those long chain of molecules to try to come up with new polymers or new drugs, because otherwise it's kind of like imagine when you're dealing with organic chemistry, you have each word, it can be like 100,000 symbols long, right?
Yep.
So it's an insane amount of work for human chemists to do, and it's actually becoming a big business, right? And in terms of cancer aiding doctors in making diagnosis, like image recognition has already gone into that a long time ago. We're just starting. So I think one of the big things will be basically integrating NLP into other domains. Even like as we're getting started, like not just images and tags, but okay, how do you read a PDF with actual pictures and stuff? Combine all this knowledge, not just take the text and use it or text the picture.
So it's not a domain agnostic problem.
Yeah, basically make it work with everything.
Yeah, sure. Interesting. So with the combinations of technology now, I think that's going to start to get a little bit easier. The way that we can actually combine deep learning, natural language processing, machine learning, I think that's going to help. That's probably why we are where we are now. I guess asking the question about where we're going to be in 2020 is maybe a little bit short-sighted.
Yeah. Well, 2020, I think it's going to be, well, because of there was a lot of papers on graphs. I think there's a big interest in them. Definitely. I think that's kind of happening because I'm not even sure. Well, I guess because people started to understand the potential with it, and because of the whole multitask thing. I think when you have a lot of, so let me try to explain why graphs. When you have a lot of labels, so very frequently on the internet, right? Well, internet is a graph. Let's start with that. But on the internet, very frequently you want to do some task, right? But you don't have very much supervised data. But you tend to have a lot of data that is either unlabeled. Okay, that's a given. But you also have some kind of coincidental labels. Like for example, you have, let's say, on your Facebook, you have the numbers of likes each one of your friends has, and you have information like. But you have. So those are features, right? But they also can have labels. Like let's say each one of your friends can be a member of a certain number of groups on the internet. So we used to think that let's pass them as features. And I think today one of the big contributions from transformers and paper and is to use some things that are basically exists in there that are kind of innate. And they should not be used as features, but they should be used as priors, as a core target for your learning tasks. So let's say I'm learning, to put it in like simpler terms, let's say I'm trying to learn how to ski. Would it not help me to, in the free time, if I have free time, or if I also kind of I don't have the skis, but I have a snowboard. Helping to, trying to snowboard, to learn, like not just read about it or something, but actually doing the similar task or almost at the same time would help me along. So that's kind of basically the idea of where all of this is like being born from, right?
Okay.
But the problem is we have so many of those that especially like for example, without revealing any details right now, I'm dealing with a data set where a task comes from like a taxonomy, kind of like an encyclopedia kind of information, and have over 1 million labels. So as you can imagine, 1 million labels, that's a lot for to take in as a string of zeros and ones, even for a computer,
Yep.
And it makes a lot of mistakes. But if you make it into a graph or a tree, some kind of hierarchical structure, right? So you say take a right, take a left, then maybe after you just needs to make 4 or 5 choices to get to approximately a correct solution, right? So then you got it there, and then you can let your deep model or whatever take over. So that kind of basically this is all happening. This interest comes from deep learning, going from comparing 2 sentences to comparing millions of documents within a couple of years. That's kind of part of it is because of the hardware, how it improved. But yeah, and so
Okay.
go ahead.
So that's essentially where you see technology within the natural language space going next year.
One of the main things that will happen for sure is we will have another drop in prices in for hardware, and
Okay.
I'm seeing I've been working with with both Amazon and Google, and the competition is heating up. Like Google has released things like. Again, for example, if anybody is free to use their 64 gigabyte TPU,
Mhm.
which is so if you have a Gmail account, which is kind of interesting. It's like NLP for everyone. You can log on. You can go ahead and use a 16 gigabyte GPU, 64 gigabyte TPU. That's a value of well, if you were to purchase ones, probably 50,000 bucks more. They're just giving it to you to use anytime you want to. So definitely they have the resources to throw at the problems. So with that said, it's yeah, the models will get deeper and deeper, but I don't see any kind of revolutionary architecture coming up. Like at least, well, I mean, might be surprised, but I think it will take another 3 or 4 years when there's going to be another jump in completely in computer technology altogether.
Awesome. And then, Danis, if you could give one piece of advice for anyone that's kind of considering entering the world of natural language processing, machine learning, what would that be?
Go ahead. Don't first of all, don't hesitate about not having. A lot of people I have talked to have spoken about how okay, do I need a degree? Yes, it's nice to have it's nice to have a degree, of course. Usually, let's face it. Okay, companies usually, if you don't have any kind of education, it's kind of bad. But without that, you don't need a PhD in machine learning. You don't even need a degree in computer science. There again, as I mentioned, I think what's the guy who started the deep learning thing, Geoffrey Hinton, the Turing Award winner of this year. I think his major was psychology, and his PhD was psychology, also with some artificial intelligence. But so he was not a mathematician in any way. And a lot of people that I work with personally, that are just as good as me, better than me. They're like we have a guy that's I think well we have physicists, right? But we have some people who are biologists, and we have nutritionists, and everybody's because I think data science and especially NLP is this day it's very much kind of a hands-on thing. You open a notebook, you take some classes, and one of the main things you learn by doing. So don't spend too much time reading the notes and reading the slides. You use the basically top-down approach, or bottom-up, whichever they are. Not the classical way. Whenever you see something interesting, just find the code and try to understand it and try to run it or implement it, and only then go into and try to read the formulas, because I assure you'll forget them anyway. So unless you really want to, you don't really need to know statistics these days to do machine learning or NLP either. That's also not true. So don't bother taking a math class until you have to. Just refresh yourself on some stuff when you need to. Basically,
So
just go ahead and get in it, and in 6 months or so, even if you don't know anything at all, you'll probably be working in the field.
yeah, so practical experience you would say is really important to make that first step into.
Yeah, by far, yeah.
Perfect. Well, look, Danius, that's it for today. Look, a real pleasure having you on the webinar. Looking forward to continue staying in touch and working with you and seeing how things are going for you at Aon. Thank you so much.
Thank you. All right.
Looking forward to hopefully having our next episode. And if you know any speakers or you have any interesting topics that you'd like to discuss, then reach out to myself and we can look to get something set up as soon as possible. Thanks for attending, guys.
All right. Thank you. All right. Bye bye.